স্যার আপনি মিউট করা।
শোনা যাচ্ছে এখন? হ্যালো।
হ্যাঁ স্যার, এখন এখন শোনা যাচ্ছে।
ওকে। Okay, today we'll start with another method of differential equations, method of variations of parameters. This is the method for finding particular solution of a differential equations, actually linear differential equations with inhomogeneous. Remember it. The first condition is we will find out the particular solution of a differential equation with this method, variation of parameters method, to find out the particular solution of inhomogeneous linear differential equations. Actually, this method credited to the Joseph Louis Lagrange, a classical method to find out the particular solution of a inhomogeneous linear differential equation. We today we examine a method, this method for finding a particular solution yp of a non-homogeneous linear differential equation. Actually, this theory developed by Joseph Louis Lagrange very earlier, his lifetime 1336 to 1813, which is known as variation of parameters method. And before examining this powerful method for higher order differential equation, we revisit the solution of linear differential equation first order and second order. Actually, we will test this method with first order and second order. The discussion under the first finding the section in optimal and motivated the main discussion of this section is linear first order differential equations. Suppose this is the first order because the highest derivative is 1 dy dx. This is the first order, and this is the non-linear because right hand side is not 0, and in homogeneous also. This is the linear actually, but non-homogeneous. So this is the linear first order differential equations, and assuming px, and this was qx in our previous lecture. Px and f of x are continuous on an interval, some interval I. Using integrating factor method, we can solve this differential equation. Then the solution can be found y equals to c1 e to the power, the integrating factor will be what? Coefficient of dependent variable, right? P. Integration e to the power minus integration of px dx plus e to the power minus px dx. This is the actually solution we can find out. The foregoing solution has the same form in the given. Namely, suppose the solution was what? After solving linear differential equation of first order, solution was what? Y equals to complementary function yc plus particular integral for right hand side. Okay, this was the solution of types, and in this case this is a solution of the associated homogeneous differential equation. If we write the right hand side is 0, then it will become homogeneous linear differential equation. So in this case, the particular solution yp equals to e to the power this. We have solved these types of differential equation. Actually, this is the p unknown with unknown function x. It may be constant also. This is why we are finding these types of solution. So this is a particular solution of a non-homogeneous equation 1, and it means of motivating a method for solving non-homogeneous linear equation of higher order. We propose to pre-derive the particular solution these types by the method of known as variation of parameters. That means um, we are going to another method, variation of parameters. So to solve this linear differential equation, which is non-homogeneous, suppose y1 is the known solution of the homogeneous equation 2. That means this equation, right? This is the homogeneous equation. Y1 be the solution. Then it will be satisfied with 1. Y1, right? Just putting y1 in replace of y, we get this one. It is easy to show that y1 equals to, this is the trial solution for this. Okay, in our previous lecture, linear differential equations, you must know about this. Y1 equals to e to the power, the coefficient of what will be y1, dependent variable here, p. So is a solution, and because the equation is linear, so c1 y1 is a general solution. Okay, the variation parameter consists of finding a particular solution, but you have to find out the particular solution of one. That means this equation, to find out the particular solution, we must know about the solution of a differential equation. There are three types of a differential solution of differential equation. One is singular differential singular solution, other is particular solution, other is general solution. So general solution will consist of some unknown c constant function with constant mixed with constant, and after assigning some initial or initial or another value of c1 constant, then the total solution will be particular solution. There will be no constant. So variation of parameter consists of finding a particular solution of one in the form yp equals to y1x, u1x, y1x. These types of solution. Okay, these types of solution will be called general solution. Sorry, particular solution with the variation of parameters method. In other words, we have replaced the parameter c1. Just this is the actually general solution. We have replaced c1 with u1x, right? And comparing with these two solutions, this is the actually general solution, and this is the particular solution, right? So actually there is a difference between these two solution. One is c1 is replaced by u1x, understand? And this parameter c1 is replaced. This is why it is called variation of parameters method. We are replacing constant to find out the particular solution of the differential equation. This is why this method is called variation of parameters method. Now substituting yp u1 y1 in equation 1, we get this. This is the product rule. ddx of u1 y1 plus p of x u1 y1 equal to f of x. Just replacing y u1 y1. Okay, just in this differential equation, this is the first order linear inhomogeneous differential equation. So just replacing y, this y with what, u1 y1, we get this. This is the actually UV process. UV process, you must know, u into differentiation of p plus b into differentiation of u. Then we get this by product rule. We can write this one. Actually, this becomes 0 by the equation 4. This is the homogeneous form of our right hand side 0. This is the homogeneous form, linear differential equation of homogeneous. So using this equation, this is also just replacing y1. Using this equation, this equals to 0. Then we get y1 du1 dx equals to f of x. By separating variables and integrating, we get u1, right? du1 equals to f of x divided by y1. Yes, this integrating on both sides, we get integration of du1, what will be u1, and integration of this will be this, f of x divided by y1x, remember it. And hence the sought after particular solution will be yp equals to what will be u1 b1 equals to what u1 y1 equals to what is this integration. So particular integration can particular solution can be written as y1 integration over f of x divided by y1x. So from the fact that y1 equals to e to the power minus integration of px dx, we see that the last result is identical to 3. This is the actually 3, just replacing with this. So this method is actually called variation of parameters method. Now we can examine with the second order differential equations. This is the second order linear differential equations, and this is non-homogeneous because right hand side is not 0. So this, by we can begin with by putting equation 5 in the standard form. Y double dash y1 dash first differentiation. Just this is the standard form, right? So the particular solution will be y equals to what will be u1x and y1x, u2x, y2x. Just this is the difference because there are two parameters replaced because this is the second order differential equation. u1x, y1x and u2x, y2x. There are second order. This is why the particular solution will be this. So we have to replace two solutions. Actually, our complementary function, that means general solution will be what? Of these types of differential equations, we get the general solution c1y1x plus c2y2x. We have to replace these two parameters c1 and c2, right? Just replacing these two parameters, we can write the particular solution y equals to y1x u1x y1x plus u2x y2x. That means we have to replace c1 and c2 parameters in yc can be replaced with the function u1 and u2. This is why it is called variable parameters or parameter variation of parameters. So this is the particular solution of these types of differential equation. That means equation 6. To answer these questions, we have substitute 7 into 6 with the product rule. Same product rule, UV process method. Just taking a differentiation on both sides, we get this. And the double differentiation will be this. From 4, we get 8 terms. Okay. From 2 terms, after UV process, we get 4 terms because these 2 will give a differentiation of U1 into differentiation of y1, okay, plus y1 into differentiation of u1 and u2 into differentiation of u2 plus y2 into differentiation of u2, right? So after again differentiating from this, we get these two, and from this we get these two, and from u2 y2 dash we get these two, and from the last one y2 u2 dash we get this by UV method. Understand everybody? Now substituting these two values are foregoing derivatives into equation number 6. Okay, this equation, just putting these values yp, these values after taking common, this equals to, and this will be become 0. Understand? So we can write this one UV process, this is UV process, and p into this, and after this is the last term. So ddx can be taken common, okay, p into this and q into this equals to f of x. So from this equation number 8, we can write u1 and u2 will be satisfied if this equals to 0, and this y1 u1 dash plus y2 u2 dash equals to 0. So reduces to this will be 0 and this will be 0. So we get this one equals to f of x. That means y1 dash u1 dash plus y2 dash u2 dash equals to right hand side f of x. So we now have our desired two equations. Okay, by Cramer's law we can solve this two equations with derivatives. Now after can be expressed in the form determinant form, just solving in y1 and y2. So u1 dash will be w1 divided by w, and this one, and u2 dash will be this. After solving this, we get, now w will be determinant of the variable y1 y2 and y1 dash y2 dash, and w1 will be right hand side column and this column, okay, y2 y2 dash, and w2 will be left hand, first column will be y1 y2 y1 dash, and right hand side. So we get u1 dash and u2 dash using these two these determinants. Then we get the particular solution. Actually this method is called variation of parameters method. Okay, method of variation of parameters. Actually these types of different second order differential equations, and this is the linear differential equations we have studied. and this is the right hand side is not 0, there is a x. So this is the linear differential equation with it in not homogeneous. Remember it, in homogeneous differential equation, and this can be written as like this. So complementary function of these types we studied now. Y can be written as C1u and C2b. Okay, C1 and C2 are the constant or parameters, right? Now we can replace this C1 and C2 with ub. Okay, then u and b are the integral solution of 1. Integral solution of 1. Then this left hand side will be 0. D square y dp dy and qi equals to 0. That is u2 plus p u1 and plus q u equals to 0, and for first one, and next for b2 another parameter b2 plus p b1 plus qb. First one is u and another is b, just replacing this capital D. Now let us replace the constant c1 c2 by another parameters a and b, which are some function of x. So this consider y equals to au plus bb the general solution, right? Au plus bb the general be the solution of 1. Now differentiating 4, we get dy dx equals to this, just ub process. Then a and b satisfy the additional condition, this one equals to 0, this one equals to 0. Okay, au1 bb1 equals to 0. U into a1 plus b into b2 will be what? Dy dx. Now differentiating again 5, just okay, we studied method of variation of parameters. In first part we have studied we developed a theory for solving the for solving a variation of parameters method to find out how to find the particular solution. Okay, how to find out the particular solution of a non-homogeneous linear differential equation method. So this is variation of parameters method. Actually this is the standard form of second order linear differential equations and not homogeneous, right? Because right hand side is not 0. So we have found that we have developed a theory in previous section how to find out the particular solution by variation of parameters method. Actually we after solving we get this the complete primitive au plus bb is the complete solution. Now apply the method of variation of parameters to solve this second order linear differential equations and not inhomogeneous. Okay, so let us first find out the complementary function, the solution of the linear homogeneous differential equation, because taking right hand side is 0, just taking left hand side and right hand side 0, we get this form of differential equation. Now if we try to solve this homogeneous linear differential equations by constant coefficient method, the complementary function taking y equals to e to the power mx be the trial solution for this, we can write this differential equation capital D square y plus 4y equals to 0, where capital D is the ddx of y. Now if this is with the trial solution y equals to e to the power mx, then this can be written as m square plus 4. That means m equals to plus minus twice y. That means we get two complex roots. So for two complex roots, the complementary function can be written as y equals to c1 sin twice x plus c2 cos twice x, right? This is the complementary. We have studied more and more about and studied more example to find in constant coefficient method for repeated roots, for different roots, for complex roots. Okay, how to write the complementary function, general solution of complementary function. So y equals to c1 sin 2s plus c2 cos 2x. This is the complementary function. Now let us consider y equals to a cos 2x plus b sin 2x be the solution of a given equation where a and b are the function of x. We can replace this c1 with a and c2 with b. Cos 2x plus b sin 2x be the solution of a given equation where a and b are the function of x. Now taking differentiation with respect to x on both sides, dy dx equals to what will be cos differentiation minus sine and multiplying with the coefficient of x 2, we get minus twice a sin twice x. From this sine differentiation cos, okay, so we get this one. Now because UV process, for UV process u into b integration plus b into u integration, because a and b are the function of maybe function of x. So just UV by UV process we get this 4 from these two. Okay, now choosing a and b such that this will be 0. A1 cos 2 a1 cos 2x b1 sin 2x will be 0. Okay, so dy dx what will be after putting this equals to 0, 2b sin cos 2x minus twice a sin 2x. We get this is the first differentiation. Now again differentiating this one with respect to x, so taking ddx on both sides, d square y dx square equals to, from these two we get 4. Okay, UV process u into b 2 cos 2x differentiation of b will be b1 plus twice b into cos differentiation what will be minus sign and multiplying with the coefficient of x, that means multiplying by 2, then we get 4 b sin 2x. Similarly from these two, just UV process, we get this one. Now putting the value, these two values d square y dx square and dy dx in the given equation. The given equation what was this. Okay, now putting the values of double differentiation, second derivatives value, the given equation, we get this is the second derivatives value plus 4 into y. This is the y equals to this and equals to right hand side. So from this line we can write 2b1 cos 2x minus twice a1 sin 2x equals to 4, and this will be cancelled, right? This and this will be cancelled. 4a cos 2x, 4a cos 2x will be cancelled, and 4b sin 2x, 4b sin 2x will be cancelled. So we get only this one. So twice a1 sin 2x minus 2b cos 2x equals to minus 4 tan 2x. This is the equation number 2. Now from equation 1 and 2, equation 1 a1 cos 2x b1 sin 2x equals to 0, and 2 is the this one. Now we can solve this equation 1 and 2 by cross multiplication method. Okay, this is the a1 cos 2x minus b1 sin 2x equals to 0, and 2a1 sin 2x minus 2b1 cos 2x plus 4 tan x equals to 0. By cross multiplication method we can write this one. Okay, from this we can find out a1 equals to this and b1 equals to this. The a1 is the first differentiation of a and b1 is the first differentiation of b. So if we remove this differentiation, a equals to will be just integrating on both sides. Okay, integrating on both sides we get a equals to 2 into integration of this one. Okay, integration of this is the a1 value 2 into cos 2x minus 2 sec x sec 2x. So integration of this will be this one. Sec x integration what? Log sec x plus tan x. So b equals to what will be just integrating this on both sides. 2 into integration of this. So sin 2x integration we get minus this one. So hence the complete solution, just putting the a below of AB, we get this is the complete solution for this. Apply the method of variation of parameters to solve x square d square y by dx square plus x dy dx minus y equals to x square d to the power x. This is non-homogeneous second order linear differential equations. Now let us first find out the complementary function. That is the solution of this. Left hand side equals to 0. Now if y equals to e to the power mz be the trial solution, mz be the trial solution, then z equals to what will be? Z x equals to e to the power z. That means capital D equals to d del del z, d dz hobe. Now this can be written as auxiliary equation will be y equals to e to the power mz be the trial solution, and after this m square minus 1 equals to, that means m equals to plus minus 1. So complementary function can be written as c1 e to the power minus z plus c2 e to the power z. Now c1 divided by e to the power z plus c2 into z. E to the power z equals to what? X. Okay. So y equals to c1 divided by x plus c2 into x. This is the complementary function. So the general solution y equals to a divided by capital A divided by x plus capital B into x be the solution of the given equation, where a and b are the same some function of x only. Now taking differentiation, first differentiation on both sides of this solution, dy dx equals to a1 divided by UV process. A is the function of x, 1 by x is also the function of x. So a into 1 by x differentiation what? Minus 1 by x square, and 1 by x into a differentiation what? A1. Similarly from this we get to b1 into x plus b into x differentiation what? 1. So only b. Now choosing a and b such that we have to choose this differentiation a and b such that this b1x and this is a 1 by x will be 0. Okay. So dy dx what will be? This is the equation number 1. Remember it. Dy dx what will be? Just putting this equals to 0 only, minus a divided by x square plus b. Now again differentiating on both sides. D square y dx square will be minus a 1 by x square plus a 1 by x square differentiation what? Minus 1 by x cube. 2 divided by x cube. So we get this. And b differentiation what? B1. Now putting these two, all these values in the given equation. Given equation is this. Okay, x square d square y by dx square plus x into dy dx minus y equals to x square e to the power x. Now d square y dx square plus 1 by x, just dividing by x square on both sides. Okay, dividing by x square on both sides. 1 by x dy dx minus 1 y by x square equals to e to the power x. Now d square y dx square value this, second derivative value, and this is the first derivatives. First derivatives value is this, given by this value. Okay. Now second derivatives value is this one. Just putting this. Then y values what? Y by x plus bx, just general solution, equals to e to the power x. Now taking similar term will be cancelled. Now we get just minus a1 by x square plus b1x equal to e to the power x. A by x cube and this a by x cube and twice a by x cube will be cancelled. Okay. So b by x and b by x will be cancelled. This is why you get minus a1 by x square plus b1 equals to e to the power x. This is the equation number 2. Now we have to solve equation 1 and 2. Understand? Dividing equation 1 by x and hence adding with 2. Dividing equation 1 by x. If we divide by x, we get only single b1. Okay. And there are only single b1. So after adding we get a1 by x square plus b1 minus a1 by x square plus b1. a1 by x square, a1 by x square will be cancelled. So 2b1 equals to e to the power x and b1 equals to what? Half e to the power x. Just integrating, we get b equals to what will be? Half e to the power x plus another constant. This will be c3. Remember it. So from equation 1, a1 by b plus b1, putting the value of b1 in equation 1, we get a1 by x equals to this. a1 equals to what will be? This equals to 0, a1 equals to minus half x square ex. So just integrating on both sides, we get a equals to, this is the UV process method. We have to apply UV process here. Differentiation of u into differentiation of b plus b into differentiation. Sorry, this is the integration UV process. Okay, u into integration of b minus differentiation of u integration of b. Okay, then again integration. Okay, again integration. So the x square integration what? X cube by 3 e to the power x differentiation e to the power x, and x square differentiation what? Integration what? X cube by 3. Now again integration, that means UV process. So u will be what? X cube. Okay, x cube is the u into integration of e to the power x minus x cube differentiation e to the power x integration. Just putting the values of integral x square, we get this one, e to the power x formula e to the power x, and this is the another UV process, another UV. So u into integration of e to the power x minus differentiation of x 1 and e to the power x integration, we get this one. So the complete solution, particular solution, y equals to a divided by x plus bx. Just putting a values of a and b. This is the result. Okay, after integrating, we get a1 equals to this. Okay, integration of this will be x square into e to the power x will be this, a equals to minus half x square u and ex will be b. This is the wrong. Okay, this is the wrong procedure. Now x square into integration of u integration of b minus u differentiation into integration of b. That means x square into e to the power x integration e to the power x minus x square differentiation what? Twice x. Okay, and e to the power x integration e to the power x. So again UB process. Okay, x into u integration minus u into u differentiation integration of b. So we get this total solution, and the C4 is the constant. So this is the actually particular solution. Now applying the method of variation of parameters to solve this similar process, d square minus 2 dy equals to e to the power x sin x. Now using similar process, we get the complementary function, taking y equals to e to the power mz as the trial solution, where x equals to e to the power z. We get two distinct roots, m equals to 0 and 2. So complementary function what will be? Y equals to c1 into e to the power 0 into x, that means 1, plus c2 into e to the power twice x. Okay, so this complementary function, the solution can be written as y equals to a plus b e to the power twice x, be the solution of the given equation, where a and b are the parameters with the function of x. Just taking y equals to this and first differentiation this, choosing a and b such that a1 plus b1 e to the power twice x will be what? 0. So dy dx transform to 2b e to the power twice x. So double differentiation of this, we get another two term using UV process. Okay. Now putting all these values in given differential equation, we get b1 equals to this one. So equation 1, solving equation 1 and 2. Equation 1 and 2, we get the particular solution. Okay, just solving. putting a equation value of b in equation 1, then we get a equals to this. So a y equals to a plus bx. Putting the value of ab, we get the complete solution. Understand?
Yes, sir.
Okay, now undetermined coefficient method. Okay, what will be the undetermined coefficient method? This is the actually nth order differential equations. And this complementary function can be written as yc equals to c1 e to the power x plus c2 e to the power bx if n equals to 2. That means second order. For second order, we can write complementary function, and for nth order, particular integral can be written as like this. Okay. Now, just we'll try to solve how to solve differential equation by undetermined coefficient method. Okay, this is the second order differential equations and not homogeneous. So this can be written as m square minus twice m equals to 0. Here y equals to e to the power mx be the trial solution. Then we get two distinct roots. M equals to what? 0 and 2. So the complementary function can be written as y equals to what? C1 e to the power 0 into x plus C2 e to the power twice x. So the particular integral can be taken as y equals to a into e to the power a sin x plus b into e to the power x cos x. Actually, this is the particular integral.
স্যার কই এটা তো দেখতেছি না এখানে।
Okay, undetermined coefficient method. There are actually two part. First one is superposition approach. Now, as an introduction, this is the actually nth order non-homogeneous linear differential equation because right hand side is not 0. This is the nth order. Okay, so the complementary function yc of the general solution of the associated homogeneous differential equation, because right hand side is 0, homogeneous form, you can write just taking left hand side equals to 0, we can write the homogeneous form. Okay, so method of determined coefficient, undetermined coefficient. The first of two ways we shall consider for obtaining a particular solution yp for a non-homogeneous linear differential equation is called method of undetermined coefficients. The underlying ideas behind the method are conjecture about the form of yp. Okay, the differential equations such as the coefficients ai I equals to 0 to n are constants. The coefficients ai, this a1, n minus 1 up to a naught. Okay, all will be constant, and gx is a constant k, a polynomial function or exponential function, etc. Sine function, cosine function, like this, or product or sum of these types of functions. So general solution of using undetermined coefficient method. Suppose this is the second order non-homogeneous linear differential equation. If we take the left hand side equals to 0, then it becomes homogeneous, and the solution will be after taking using the constant coefficient method, m square plus 4m minus 2 equals to 0, then we get two complex roots. Okay, we get two roots, m equals to minus 2 minus root over 6 minus 2 plus root over 6. Hence the complementary function is can be written as c1 into e to the power this plus c2 into e to the power second roots into x. Now this now because of the function of gx, the quadratic polynomial, our right hand side, this is the quadratic polynomial. Let us assume a particular solution that is also in the form of quadratic polynomial. That means yp equals to x square plus bx plus c. Okay, just taking these types of solution. A is unknown and b is also unknown. X square plus bx plus c. This is the particular solution. Now we seek the we try to determine the specific coefficients of a, b, c. Okay, just we have to find out the a, b, and c. This is why it is called undetermined coefficient method. And we'll try to find out the coefficient a, b, and c using this method. Now the coefficients a, b, and c for which yp is a solution of 2, substitute yp is that derivatives. Taking first different derivatives, yp dash, what will be twice x plus b, this will be 0. Double differentiation, what will be twice a x will be 1 differentiation and b will be 0. Okay, because abc are constant, remember it, not function of x. So into the double dash. Now the given differential equation 2 becomes equation 2, which one? This is the given differential equation. Just putting what? Double differentiation value, first differentiation value, and y value in this equation, we get this equals to 2x square minus thrice x plus 6. Because the last equation is supposed to be an identity, the coefficient of like power of x must be equal. Okay, this is the like term. Okay, x square coefficient, x square coefficient, x coefficient, x coefficient, and constant term, right? So equating the coefficients of like term on both sides, we get minus twice a equals to what? 2, and 8a minus twice b equals to what? Minus 3, and this constant equals to 6, right? Now solving this, a equals to what here? Minus 1, and putting the value of a here, we get the value of b. B equals to what will be? B equals to minus 5 by 2, and putting a b value, we get c. That means the particular solution will be what? Yp equals to minus x square minus 5 by 2x minus 9. So general solution what will be? Complementary function plus particular integral. Very easy. Very easiest method. Understand everybody? So there are only 3 steps. This is the step 2 will be the considering particular integral, and step 1 will be the finding complementary function. There are only 3 steps. Now a particular solution using undetermined coefficient, another example. Find a particular solution of y double dash minus y dash plus y equals to 2 sine thrice x. That means this is the second order, because second derivatives present here. This is the second order linear differential equations, and it is not homogeneous. First of all, we have to take the homogeneous form. We have to find out the complementary function, right? So a natural first guess, the particular solution would be a sine thrice x. Particular solution will be just taking constant 2a. Okay, so a sine thrice x, but because the successive differentiation of sine thrice x produces sine thrice x, cos thrice x, successive differentiation. Okay, sin x differentiation what? Cos. This is why in successive differentiation after sin thrice x, cos thrice x also produced. So we are promoted instead of to assume the particular solution that includes both of these terms. That means particular solution will be what? A into cos thrice x plus b into sin thrice x. Remember it. We have to take this as a particular solution. Understand everybody? So in trigonometric function, if the coefficient more than 1, then we have to take this type in this way. We have to take the particular solution in this way. a into cos thrice x plus b into sin thrice x. If there are in replace of 3, if there are 2 or more than 3, then we can take a into cos something x plus b into sin something x. Okay, but this y double dash minus y dash plus y, this was the previous, by previous method complementary function we can write. Okay, so m square minus m plus 1 will be 0, then we get the complementary function. So just how to write the particular integral, this. Now taking differentiation, differentiating yp and substituting the results into the differential equation as the previous example, we get double differentiation is this, and first differentiation putting, then yp is this, we get this one. Okay, now equating the like term on both sides, equating like term on both sides, that means sin thrice x coefficient, sin thrice x coefficient will be equal. Okay, but here in right hand side cos thrice x absent, this is why we can take this 0 into cos thrice x in right hand side, just to match the like term. Okay, 0 and this cos thrice x term will be 0. Okay, so from the resulting system of equations we get minus 8a minus thrice a equals to thrice b equals to what, 0, and thrice a minus 8b equals to what, 2. Now solving, we get a equals to 6 by 73 and b equals to what, minus 16 by 73. Just solving, you can apply any method for solving, substitution method or determinant method or cross multiplication method, any one method. So the particular solution of this given can be written as yp equals to this. Okay, so so total solution can be written as how, y equals to complementary function plus particular integral. Okay, so find a particular solution. This is why we have we have written the second part. Now another one, this is the given second order differential equations. This is the mixed with polynomial function and exponential function, remember it. The first step, find out the solution of associated homogeneous equation. Right hand side will be 0. Okay, making homogeneous linear differential equation. After solving this, taking y equal to mx be the trial solution, then we can write complementary function what, m square minus twice m minus 3 equals to 0. Then you get two roots, one is minus 1 and another is 3. So the complementary function will be what, complementary function equal to c1 into e to the power minus 1 into x plus c2 into e to the power thrice x. Now next step, similar process, there are the presence of 4x minus 5, another function. Okay, and this is another function, multiplied function. Okay, so next, presence 4x minus 5 in gx suggests the particular solution includes a linear polynomial, and further, because of the derivatives of the product x into e to the twice x produces twice x into e to the power x, and another produce what, e to the power x. Just taking differentiation of this, we get this, we get another this after differentiation. So there are three function mixed. You also assume that a particular solution includes both this one because this is the second order differential equation. If so, first derivatives will be this, consist of this, and second derivatives will be this. So in other words, z is the sum of two basic kind of functions. So zx, this is the zx will be the sum of what will be z1x and z2x. First function will be polynomial and another will be exponential function. Okay, now corresponding to the superposition principle for non-homogeneous equation, suggests we seek a particular solution yp equals to, there are two function z1x and z2x, so yp1 plus yp2. So yp1 will be solution of what will be linear function, so 4x minus 5, that means gx. Okay, x plus b, taking this solution yp, Okay, yp2 will be the second one will be c into x e to the power twice x, and this will be e to the power twice x, c e. Okay, d not taken because the differentiation, capital D is the operator of differentiation, this is why. So second one will be the function what? First one will be a function ax plus b, linear function, and another one exponential form. So twice c into x into e to the power twice x, and another is e to the power only twice x, e. So yp will be sum of these two particular. Okay, this one. So into the given equation 3, the grouping like the term, just putting the values and double differentiate, taking first differentiation, second differentiation, and then putting, we get these values. Now equating the like term, coefficient of x minus thrice a, and constant term will be this. Okay, so e to the power twice x term, e to the power twice x term will be this, minus thrice c will be to the power twice x term, here 0. Okay, here 6, right, 6. So e to the power twice x is the absent here absent, so twice c minus 3 will be 3e equals to 0. Now solving, we get this here a, and putting a here we get b, and c is the only minus 2, so from putting c we get e values. So we get a equals to minus 4 by 3, b equals to 23 by 9, c equals to minus 2, and e equals to what? Minus 4 by 3 consequently. So particular integral can be written as just putting the values of ABC here, e. Okay, we get this one. Now next step, the general solution will be what? Complementary function plus particular integral. Okay, this is the actually result.